Hello students, so today's session is about the ICSE class 10 revision on the refraction part. So as all of you know that the refraction has the basic concept of refraction. You will get questions from there probably, right? And what is the law of refraction and what happened, what is the dependency between the the velocity, wavelength and frequency during refraction. Then the different application of refraction. So the basic, let me tell you what basic like light when it's passing from medium one to medium two. So light if this is incident ray, so it will be either there is a bending of light. There is a bending of light. Light getting bent when it is passing through other media, and this is called the diffraction. So light light what is inside the light like velocity c is equal to f lambda. So velocity of light is f into lambda. So f is the frequency of light, lambda is the wavelength. So what happened that during the refraction, frequency is not getting changed in refraction. It will be unchanged. So what changed? The velocity of light getting changed, and it depends on the optical density of two different media, right? And also the wavelength. As you know, wavelength of red and wavelength of violet. Okay. So what happens that lambda of red is greater than lambda of violet. Okay. So the refraction will be different for in case of red and violet light. So different light is presented by different wavelength, and different wavelength will cause different refracted angle. Okay. So what happened, because this refraction depends on the refractive index and the velocity of light. So velocity of light will change. That's why the bending happened, and that's depend on the wavelength of light and the optical density of the two media. So this is the very basic about refraction. Now, in case of critical angle. So what is critical angle? Critical angle means, let's say this is a denser medium, this is a rarer medium. So as you know that when light is passing from denser to rarer, what happens that it will go away from normal. It will go away from normal. So there will be deviation. So this will be the refracted angle, this is the incident angle. So refracted angle will be higher. So for certain incident angle, the light will go in this direction. That means the refracted angle R will be equal to 90 degree. Okay, the refracted angle will be 90 degree for certain case, and that case light will pass through the interface of the two media. So that time this critical angle I will be symbolized with the C. C is the critical angle. So critical angle is depends on media to media, right? For our case, what we have seen that in case of prism and air, the critical angle will be 42 degree. So critical angle means a certain incident angle for which the refracted angle will be 90 degree. Now, this has been observed that if the incident angle is greater than the IC, if I greater than the IC, then light will go back in the original media, right? Light will go back. So it's called the total internal reflection. So light is reflected back in the same media, but it was supposed to do the refraction. Okay. So this is very important. That means if incident angle is greater than the critical angle, light will go back to the original media. Fine. Now, applying this, we are having the binocular. We are having different application where we are using prism as a reflector. Prism as a reflector, right? Okay. So you are having the different questions like where we will be having the prism, right? So let's say for this prism, what happens is a right angle prism. So and let's say this is 45 degree, this is 45 degree. If a light is coming like this is incident light. So this is the air media, this is the glass prism media, this is again air media. So air to glass incident angle is 0 degree because it is passing through the normal. So I is 0, R will be 0. So light will pass from air to glass without any deviation. After that, it will fall here. It's supposed to refract from glass to air. That time, the so this is the incident angle. This is 45, this is 90, this is again 45, this will be 45 degree. So incident angle is 45 degree, where 45 degree incident angle is greater than the critical angle of the prism, right? So what happened? Light will get reflected and it will go here. Again, it will be refracted here. So refraction, reflection, refraction. With this mechanism, the light will bend like this. So prism is acting as a reflector in this case. Okay. So these are the type of questions like we will be getting a different pattern of prism and different making of prism and different incident angle. So next is the prism will be used as in the binocular, right? What happened? So these are all the binocular. What happened? What you are doing? The light will come like this. It will reflect there. Again reflection. Back like this. So what happened that the incident angle there will be the 45 degree. So reflected angle 45 degree. Again it will incident here as in 45 degree. Again it will be 45 degree. Okay. So this way what happened that the light is coming back like this 180 degree deviation. So here two reflection happen. Reflection 1, reflection 2. Why reflection happened? The total internal reflection because 45 degree incident angle is greater than 42 degrees. So this is the key concept. Okay. In other case we get that where light is, let's say light fall in 30 degree. What happened? You will receive the refraction of the light. So this way you have to practice for different cases. Let's say I have a prism, okay, where the light is passing like this, and I have seen that the incident angle is 40 degree. So what happened? It will refract like this because 40 degree incident angle is lesser than the critical angle. Okay, so this way you have to do practice for this part, and this is very important, and sometimes students are facing issue to complete this. So you can go like this. Okay, so this way I will be highlighting different case studies, and that will definitely help you to understand. Next I'll come with the what is apparent depth, right? So apparent depth, you may have idea, but I will come in different session like what is electromagnetic induction. You know that electromagnetic in this session just very quick brief you about small part of electromagnetic induction. Like whenever, let's say there is a magnetic field here, magnetic field, and inside this you will be having a conducting wire here, right? Conducting wire. So if you mechanically move this conducting wire, there will be an induced EMF happen in this wire and a current will flow. That's called induced current in this conducting wire. So change in magnetic field cause induced EMF. So this is the famous Faraday's law of electromagnetic induction. There Faraday is saying that EMF is equal to with minus n phi 2 minus phi 1 by t. So phi 1 is the initial flux and change in flux phi 2 with certain time t. So what is phi? Phi. So now before that, these are the magnetic field. Magnetic field are presented by the B vector, and phi is the BA cos theta, right? B dot A, right? Or B for magnetic field, A is the area. So phi is the magnetic flux. We are saying is the flux, right? F for US. So whenever in this field, if some coil is moving mechanically, the exposure of magnetic field will be changing that coil. That cause induced EMF in the coil, and that cause induced current. Okay, just follow my session. I'll highlight the key concept, and I believe that will really help you for well preparation before ICSE class 10 exam. Please follow my session. Any questions, please WhatsApp me. I'll respond you with the same way. Okay, thank you.